Lastly, we talked about mainly infrastructure as a service. Means if I want to get a server, that comes under Google Compute Engine, and that comes under virtual machines in the Google infrastructure. Here we talked about GKE or Google Compute Engine. So Google Compute Engine deliver virtual machines running in Google's innovative data clusters. So there is different types of resources are there. Since we have done lab last day, you may find this type of resources like disk, image, network, firewalls, address, region zones. Some of the resources we'll talk about today. So when you're going to create any instance, we'll find 4 types of machine type. We are going to use any one of the machine type based on our own requirement. Now here you can see compute engine. Now there is different types of disk. We have persistent disk. It has some features like if you want to store some data, we'll go with this persistent disk. We have local disk. Local disk can also be attached to a particular VM. Then we have the concept of RAM disk. It is much more faster. Then we have the concept of preemptible VM. Preemptible VMs are such like, till the time, anytime it can go. So mainly the task that is not that much of important, we generally go with this preemptible VM, and its cost is very less compared to other VMs. So we'll come to know different types of disk in infrastructure as service. As much as lab we try to implement in the same domain. If you see here, last day we've done three tasks. One is how I can create an instance from a cloud console. Then we talked about how I can install an nginx server inside an instance. Then we talked about how we can create an instance using gcloud command. These 3 tasks we talked about last day, but we have some other tasks also that we have not completed last day. We can do the same task using our gcloud API documentation. If you remember last day, we have shared that gcloud API documentation. So if you come into that, you can see this is our. So let's first check that our billing account is active for the project 17322. So let's go to this billing account. First, we are going to cross check it. And you find that this is our billing account, and this billing account is active for my project 17322. So let's go to our dashboard, and here I'm just selecting the project 17322. Right, so all the services I can use under this project. Now I'm going to our compute engine. In the compute engine, I'm going to VM instance. The instances that we have created, instance are stopped. If you want, you can start those instances. Let's start those instances. Select the instance and start it. Both the instance, let us just select and start it. Since we have disabled the billing last day, so automatically those instances got stopped.
Yesterday, I disabled the billing for one of the instance, but I kept the instance 2024, but the other instance, it's gone. Did I?
Okay.
You need 2 instances going, so I can just create.
You can create those instances, but
Okay.
or you can restart those instances, because I have to complete these 3 labs that is left that you have not done. So that you're talking about here in this part.
Yeah. So the first, so the second instance I was able to get. The first instance where we did it through the GUI, I think I deleted that one. But the G
Okay.
Cloud instance, I still have it and it's running right now.
Okay, it's fine.
Okay.
It's fine. We can go with that. No, no problem.
Okay.
Not required
All
to
right.
create also.
Okay. No problem.
Just you can. Okay, yeah. Now here, see both instances are running, and I came inside our G Cloud part, and here what? Okay, now what we'll do is that we'll do some task like filtering command line output. Assume when you're working on some specific project, you'll find multiple instances are running under your project. Now you can see 2 or 3 instances, but when you actually in the actual project environment, you'll find 30 to 35 instances are running. In that case, you know how to uniquely filter a particular instance, that you can filter with the instance name. And this command like gcloud compute instances list, this we have already executed last day. You remember this, if you just control V, we can see list of instances that is available currently. Now here you can see only 2 instances there. So it is saying gcloud compute instances list, gcloud core project. So project ID. So they are asking that you have to set the project ID for existing. So you can do one thing, control V, select the project ID. From where I'll get the project ID? Project ID is here. If you go to the dashboard, here you'll find a project number, project ID, right? Just select this project ID here, since it is saying to set the same. So gcloud config set project ID. I'm using this project ID. For me, it is showing. It may not tell you from your end also. So now what I'm going to do is that I'm going to check all the list of instances. So gcloud compute instances list. So you can see here currently 2 instances running for me. This is both are in the same region, same zone. This is my first instance, second instance, and this is the first instance. Right now, what you want to do is that I want to select, assume you have 30 instances running like that. Right, I want to select that specific instance. I want to filter that specific instance with instance name. So how I can move with that? Gcloud compute instances list filter name equal to my instance 2024. You can see I have the same instance, my instance 2024, my instance, right? So I can use this command to filter only my instance. Control C and Control V. Just check. Yes, it is just selecting. If you have 30 instance, only that particular instance we can filter out. Just to check the instance details separately. Right? That you can filter multiple instances in gcloud. Similarly, I want to see all the different firewall rules are there. All the different firewall rules I want to check. So in that case, you can use the command gcloud compute firewall rules list. All the firewall rules I want to see. So you can go there, Control C, Control V. I can see all the firewall rules that is there, right? Increase. So all are default one. That is already by default be available with your instance when you create a specific instance. Now,
Hey,
you know,
I have a quick
yeah,
question.
yes, please, yeah.
So if we have billing account active, but the instances are stopped, then we will not get any charge, right?
No, if billing account is disabled for the project, then it is not going to charge.
What about no, if the billing account is active, suppose that's what I
Okay.
did. I kept it active, but I stopped the instances.
No, billing account be active always. We don't have to work on
Okay.
the billing account. You can see here, this billing account will be active always. We
So
don't
it
have
will
to
not
work.
get any charge, right?
No,
If
no. For billing account, there is no charge.
okay,
You can
okay.
see here. It's coming, I think. Manage billing account. Billing account is always active. This is if this is my billing account. This is my project.
No, I think his question is more about the whether if he has not disabled the billing account on the project, rather he has just shut down the instance or stop the instances. In that case, whether the charges will
Okay,
still be
okay.
incurred.
If that is the okay, that is the scenario. See, the point is that then it is not going to charge. But the point is that when you're working on the actual project environment, you will find that you are going to interact with different services on GCP, right? So it's possible that some of the services have stopped. It is also possible that you forget to stop some other services, right? So in that case, we should always disable the billing account for my project. So whatever the services are there under this project, for none of them, for all of them, the billing will be stopped.
Oh, so if the even if the instances are stopped, so there could still be some services running?
Assume, see that in this
Uh,
example, you are just dealing with only one or two instance, right?
right,
If you
right.
stop those instances, it is not going to charge, no problem.
Yeah, yeah, okay, okay, yeah.
Hmm. So I'm just coming into this billing account, manage billing
But
account.
it will, sorry, but it will charge the storage, of course, fees. Yes, if we disable the project, but we have occupied, let's say, 50 gigabyte of data, then we'll still be paying for that or not?
No, no, no. If you are going to disable the billing account for your project, it is not going to charge anything.
So the data will
Nothing.
be deleted then?
No, no data will be there, but you may not use it later, something like that. Or it will
Okay.
be there, you may not access it. You may access it when you are going to enable the billing account. All right. So charging will be stopped once you will stop the billing account for your project.
Okay, thanks.
Okay, so as you're talking about here, that the next step is that I want to see all the firewall rules. You can see the firewall rules using G-Cloud Compute firewall rules list. Yes. And if you want to see the system logs, you can use G-Cloud logging logs list. So you can just execute. I'll suggest execute this small commands. Now these commands, you can see the system log files for any component. See, for each and every services there is a separate logs, right? You can go in that particular path and you can see that particular logs. All the logs are visible for each services. So like this way you can get multiple command, but these are the commands. Just you can check the G-Cloud API documentation that I've shared last day. You can execute them. So I'm just sharing the same things in the communication window, or I'm just sharing the same things in the. Okay, so time is over. Let's move to the next step. The next step, we'll talk about this part. So in the next step, we'll talk about load balancing, auto scaling, and high availability. So these terms are very important when you came inside a cloud computing domain. So let's understand the idea first. Now see, what does it mean by load balancing? Is that when any particular request is coming to your instance, it will pass through this load balancer. Load balancer will forward the request in a specific instance. So GCP offer server-side load balancing, so you can distribute incoming traffic across multiple virtual machine instances. Now, load balancer not only distribute the traffic between multiple instances, but also load balance before the request will go to an instance from the load balancer. Load balancer can check the health of the instance. If load balancer find that the health of the instance is okay, then only the load balancer will forward the request to a specific instance. Else, it will say to restart, it will say that the instance health is not okay and the load balancer will not forward the request to that specific instance. That is the importance of load balancer, right? Now here, from GCP perspective, load balancing providing the following benefits. You can scale your application, can support heavy traffic. We can detect and automatically remove unhealthy virtual machine instances. Instances that become healthy again are automatically re-added. Health checking configuration used to identify healthy instances. Route traffic to the closest virtual machine. These are some of the tasks that we'll achieve with the help of load balancer. If you go inside GCP, these slides is slight advanced. These slides are very specifically for cloud engineers. So you may find that advanced topic. So we can see here the GCE Google uh, container engine. We have two types of load balancer. One type of load balancer is called global load balancer, and some other types of load balancer is called local load balancer. Now, this global load balancer and local load balancer, they have some characteristics. You can see here for global load balancer, we have HTTPS load balancer, SSL proxy load balancer, TCP proxy load balancer. Whereas in regional external load balancer, we have network load balancer, internal load balancing. So they have divided the load balancer into multiple category, and each and every load balancer has its own characteristics. Right? Okay. Then you will find another one very important term. It is called auto scaling. What does it mean by auto scaling, right? Let's give an example first, then I'm coming to this. Let's understand and the auto scaling with an example. So to understand it, I'm just moving towards draw.io. And if you go inside this draw.io, let me just draw something and just I want to cross check. Just I want to talk about the concept of uh, auto scaling. Here I'm just writing. This is for GCP, right? So GCP on 15th April GCP. Create. Now see here, we are talking about the concept related to auto scaling. So let me just write it here. Auto scaling. If you see here, I'm just checking, assume this is, I'm just writing here. People, this is the customer. Assume customer is sending a request. Customer is sending a request, and this is your microservice. Assume this is your service. So you can write here service. So coming with multiple, just write not coming. Okay, instance. Okay, I are just waiting service. So more results. Okay. Now see, I'm just taking any one of the instance examples how I can represent a specific microservice. That's why I just came here. Not getting any specific symbol how I can represent. Assume, I'm just assuming this is a microservice. This is a microservice or your VM or your VM or your VM or virtual machine that you have created a microservice. Right. So name of the microservice is user microservice. Assume this is a restaurant microservice. Restaurant microservice assume. Right. Similarly, you have some other microservices. Assume it is a customer microservice. Okay. For the time, you can think about it as an instance also where the service is deployed or running. You can think about server also. So you can use customer microservice. Right. So when the request is coming from the customer. Customer generally send a request using an UI, React UI. They generally send a request using a React UI. So assume these are the two services where the request is coming, right? It's possible at a particular time, huge amount of request is coming from the customer. So at a particular time, it's possible that 100 request came to this service, right? So what will happen is that when the request will come to this service, then Kubernetes come into picture, and Kubernetes will create multiple instances of the same microservice. It will create multiple instances of the same microservice. Okay, like this way, it will create multiple instances of the same microservice and divide the request in between all the instances of the same microservice. Same like that, right? Same like that, when huge amount of requests will come to the customer microservice, Kubernetes will come into picture and it is going to create multiple instances of the same microservice. It will create multiple instances of the same microservice. It will create multiple instances of the same microservice and divide the request that is coming in between all the instances. Right? So that is called scaling up. Right? And when number of requests is less, then automatically it is going to reduce number of instances. It is going to reduce number of instances that it's created earlier. That is called scaling down. So that scaling up and scaling down automatically happened with the help of Kubernetes container orchestration tool. That we are talking about here. We are talking about auto scaling. Auto scaling possible for your microservice instances or for your VM. So your microservice ultimately you are going to install inside a node, right? So that you're talking about here is that the compute engine offers auto scaling of automatically add or remove virtual machine instances. Now in GC, this is the idea behind auto scaling. But when you go inside GCP, there is some, if you go inside GCP, you'll get lots of terms. If you go inside GCP, you can just see here, I'm going inside compute engine, virtual machine instances. In the left side, you will see, you'll get lots of terms in the left side. Where it is, you can see compute engine. You can see lots of things are there like, see here, it's coming instance group, health check, right? Server, network, volumes. Lots of parameters are there. It's not possible to remember all step by steps as we are going to practice. It will come. that we're talking about here. If you see this diagram, it will tell you the complete things. When huge amount of request is coming from the client with the help of, as you most of the time use the React UI as an front end for your microservice. When huge amount of request is coming, it is going to increase number of instances for the instance. That is called scaling up. And when request is less, it is automatically reduce number of instances. That is called scaling down. Now, these are the instance microservices. These microservices generally, what we do in case of cloud native application is that we try to use containerized microservice. And those microservices we try to install, try to put inside a node. Okay, so this is one node, this is another node, this is another one nodes. Collections of node we generally put inside collections of node we say instance group. Did you remember this? This is the term that is used in GCP. Instance group means collection of instances. Collections of instances. Why I'm saying there is one file called, or there is one concept called autoscaler. Autoscaler is one type of policy document. Now see here, we create one autoscaler per instance group. That means one instance group contain 10 instance, another one instance group contain 10 instance, another one instance group contain 10 instance. Like this way, if we have 5 instance group, for each instance group there is an autoscaler. Autoscaler we create for each instance group. Now see here how, just not talking about, right, how Kubernetes is going to increase number of instances and decrease number of instances. That is defined based on autoscaler policy. Autoscaler policy means that have three major parameters. One is called CPU utilization. Another is load HTTP load balancer serving capacity. Another is stack driver and custom matrices. So the stack driver is mainly used for monitoring a particular service in GCP. Load balancer, just now we talked about CPU utilization. So based on these three parameters is available inside the autoscaler policy. So Kubernetes is going to do scaling up or scaling down based on this autoscaler policy. Right. So these are the things that there. Right. So step by steps, I will come into in depth, right? So that is the auto scaling part, right? That's why it is being given here like this, that compute engine offers auto scaling to automatically add and remove virtual machines from an instance group based on increases or decreases in the load. This allows your applications to gracefully handle increase in the traffic and reduces cost when the need for the resources is lower. So you just define the auto scaling policy and the auto scaler performs automatic scaling based on the measured load. Right? That you have to remember that in case of GCP, or the GCP, how number of auto scaling or auto scaling happened based on the autoscaler policy. Autoscaler policy is defined for each instance group. In each instance group, we have multiple instances. Inside each instance, we have microservices. Right? So things are like that, right? Fine. So next, another important point that is very important point, that is high availability. If you remember last day, we talked about the concept of high availability using the concept of zones. Let's talk about this concept. If you remember last day, we talked about that we have a region. We have a region, right? Assume any region. Inside a region, you have zone. Inside a region, you have a zone. So assume inside this region, you have one zone. This is another one zone. We told you that there is a standard. Standard is that inside a region, we should have 3 zones, but sometimes it can be 4 or 5 also. But the standard is 3. Inside a region, you have 3 zones. So this is the regions. So inside these regions, you can see we can define 3 zones. Right now, the point is that inside each zone we have racks. So assume this is the one zone, and inside this zone you have a rack. So this is one rack. Okay, this is another one rack. Inside the zones you have multiple racks. Inside the zones these are called rack. Right, inside the zones you have a rack. Right, similarly inside these zones also you have multiple racks. Rack means collections of server. Rack means collections of server. Similarly, inside these zones also you have multiple rack. Inside these zones also multiple rack. Inside a rack you have node. Node means server where your microservice is deployed. This is the node where your microservice is deployed. Inside a rack you have node. Similarly, I'm going to define another one rack. Inside a rack we have a node. So this is a node inside this rack. This is a node inside this rack. Right, so inside, so assume so under all rack, okay, you will find that the node is defined inside a rack like this. Node is defined inside the rack, so it is like this. So assume this is a one zone, this is another one zone. Right, so inside this zone also you have a rack, and inside a rack you have a node. So this is another one. Right, similarly you can define this multiple. Similarly you can have node inside the rack inside the third zone. Right, and you can have node you can have node in the in this zone. Node means server, means where your containerized application is running. Now see the scenario that if you have deployed a microservice, assume the microservice is running here. What is the name of the microservice? Microservice name is customer microservice. So assume your customer microservice is running here. You deployed inside this node. Right, now this is in one zone. Right, this is what this is. Not writing the name generally like Asia something, then something south, then 1A, something like that. Right? This type of naming convention we find, right, for copy, Control Z. Okay, so this type of naming convention you'll find, right. Now we can create another one, and this zone has a particular name. Assume its name is Asia South. I'm just writing some name 1B. Right, this is another one zone, and this is another one zone. Assume its name is Asia South 1C. So you can write here Asia South 1C. Right, so it should be like this. Right, now here assume you're running a microservice here, and its copy should run here also, same microservice. So customer microservice, its copy is running here, and same microservice, its copy is running here, customer microservice. So you can see here, when I say that we are running a particular service inside these zones, its copy is running inside this zone, inside this zone also. Somehow, if this zone is not available, then the copy of the same microservice will be available inside another one zone. So customer request will come inside this microservice and complete the task. So one microservice has 3 different copy in 3 different zones. One microservice has 3 different copy and 3 different zones. So using this, it is going to maintain the higher availability. So it is zone wise inside a single region. Same like that. So it is a higher availability inside zone wise. Same like that. Same copy of microservice can be available in some other region, other zones. So we can implement higher availability in region wise also, right? That we are talking about here. So what we are talking about higher availability is that using region and zones, we make our application highly available. It is the quality of the computing infrastructure that allow it to continue functioning when some of the components fail. It is important for mission critical services that cannot tolerate interruption in the service. Due to high availability, if any instance is down, then it can quickly connect with other zone instances. So like this, they can avoid downtime of the system, right? So that is the scenario, very important point, higher availability when we want to deploy our applications in cloud environment, right? Service. Our next part is we'll talk about containerization. And this is the topic that is container as a service that we are talking about now. Earlier, we talked about compute engine. Now here, when I talked about container as a service, so I want to say some points here that we are moving towards cloud native applications. Okay? The company industry is moving towards cloud native applications. Now, what is cloud native applications? Earlier, we do use SDLC phase, right? It will take long time to resolve customer requirement, slide slow. Then we came with agile methodologies. In case of agile methodologies, also automation is not mandatory. Whereas when you come to our DevOps implementation, more all the operations are automated. So in case of cloud native application, we have 4 pillars. First pillar is called microservice, that we can create using Spring Boot, that we defined as an independent deployable component, right? Spring Boot applications. We can get microservices in Spring Boot, right? Second pillar is called containerization. Containerization we implement using Docker. We always deploy containerized microservice inside a cloud using DevOps culture, using CI/CD pipeline. This is the full point of cloud native application. And these cloud native applications are much more faster during runtime. You can update customer requirement. You don't have to wait for 2 to 3 months. During runtime, you can update customer requirement during runtime, and you don't have to wait long time. It's much more fast. So industry is moving towards cloud native applications. That is the main thing, right? So when you're moving towards cloud native applications, lots of terms comes like that we should have some idea. Yes, we may not have, maybe in different category of different skill sets, but we should have some idea about these terms like VM, container, Docker, Kubernetes, microservice, cloud native applications. We should have some idea about them. That's where we're moving towards, right? How? So GKE, Google Container Engine, mainly it is used to deploy your microservice, right? So, and there, Anthos has a very important role. So let's understand them one by one, right? And then we'll execute a very good applications using Google Container Engine. So let's see it here one by. Now see here, just now told you the principle of cloud native application that have 4 pillars: microservice, container, DevOps culture, CI/CD pipeline, right? So let's talk about them one by one. First of all, this microservice, these are called independent deployable component. You can create a microservice using a Spring Boot. You can create a microservice using Node.js. You can create microservices using .NET. They're independent deployable component. Means each and every service has its own server and database. And they follow one type of decentralized architecture. Means some service you can deploy in AWS cloud, some service you can deploy in Azure cloud, some service you can deploy inside Google cloud. That is microservice, and we are this is one type of enterprise architecture. If you know, fine. If you're not familiar, I'm just giving some points. Microservice, right? Now we should know about container also, DevOps also, CI/CD also. Container, we always use container as microservice. We want to deploy containerized microservice inside a server. And that container we create with the help of Docker. DevOps is a culture that we follow. Using DevOps culture, we use CI/CD pipeline to deploy our code. The moment developer is going to commit the code in the GitHub, it will pass through Jenkins, right? From Jenkins, you're going to deploy it in the Jenkins server. Then from there, it is going to SonarQube for testing. Then it is going to Artifactory, where you should have all the Artifactory. And then using CD, the continuous deployment, that artifact should be deployed inside the cloud. That is CI/CD pipeline, right? Now here, this is a part of cloud native applications. Now we will say that why you're talking about it. GCP, Google Kubernetes Engine, has given an excellent solution to deploy cloud native application, and industry is using it. So we should know, we should familiar ourselves with these terms, right? So let's understand one by one. Let's talk about first Docker. What is this Docker? So earlier, what we do is that if you see our physical server, we have operating system. Above operating system, we install hypervisor. Above hypervisor, we try to install a VM. Each and every VM has its guest OS. These VMs actually share our actual host operating system resources. So this is said to be as an virtualization. So earlier we tried to implement virtualization with the help of hypervisor, and we are going to create multiple VMs. Now, this approach has some limitation. What is the limitation is that what you are doing, if huge amount of request is coming, you can get another one instance, VM instance, and divide the load. So that concept is called horizontal scaling. When you're going to increase another one VM instance and dividing the loads between the VM instance, this concept, you're increasing instance. So increasing an instance to handle the load, this concept is called horizontal scaling, right? That we used it earlier. So you're moving from this approach to this approach, containerization approach, where our operating system, you're going to install Docker desktop. Above Docker desktop, you're going to create a containerized application. And that container you're going to deploy inside the cloud. Now the question is that you're moving from this VM approach to containerization approach. Industry is moving. What is the advantage? Why we are moving from this VM approach to containerization approach, right? Let's understand it using this slide. This slide will give you the complete idea. If you see here, this is my host operating system. Left side is the VM approach, right side is the containerization approach. Just see here, if you have your own VM, own host operating system, your host operating system has some parameters, storage 2 TB, assume. So above hypervisor, you have the VM, and these VMs actually sharing the host operating system storage, right? Now here, if you just see, this concept is called virtualization. Now, this virtualization concept have multiple limitations. One limitation is that the subscription cost. What is this subscription cost? If you are going to create multiple VM from the host operating system, the whole operating systems will come with some subscription cost. You have to bear that subscription cost, so this implementation is slightly costlier. Not only that, you have deployed some application inside this VM, and a huge amount of request is coming from the client to handle that application that is running inside this VM, right? Right? So the performance of the VM will decrease when number of requests will increase because they have some limited resource. These VMs actually accessing the resource that is there inside your host operating system only. They have limited resource, right? So these are the limitations of the VM approach, virtualization approach. Now here, let us give some example why you are moving from VM to containerization side. Just see here. You have created a banking application inside the Eclipse IDE. Assume. So what should be the application size? Assume its size is 100 MB. Assume. And this application is running on the host operating system and its size is 700 MB. So host operating system size is 700 MB, where you have the server and you have the application size is 100 MB. That we do, right? You deploy your component as a jar inside the server, start the server, application is running. Right? Now here, just see in the right side, application size is same. That is a banking application. What you are using is that you are including here one operating system size 700 MB, right? Above this operating system, your server is there. Above server, your application is deployed. Correct, right? What you have done is that the same things how it is done. See, what is important? Host operating system is not important. Importance is your application size. So application size is same. Banking application size, the project that you have created in the Eclipse. Whereas in case of containerization, host operating size start from 1.12 MB. So what you find is that when I'm moving from VM approach to containerization approach, application size is same. The application that I want to deploy, the host operating system size is less. That means what? With containerization, we need less resource. With containerization, we need less resource. That you're talking about, that is one of the advantage of using containerization. If you see here, if you have created a microservice using a Spring Boot, right? What you do is that you create an image first for this microservice, and from image you create a container with the help of Docker. And that container you are going to deploy inside a node. That node is inside the rack. That rack inside the zone. That zone, right, is inside the data center. The data center is inside the cluster. This is how the things, right? In all cloud, same type of configurations, right? So what we find is that we are moving from virtualization to containerizations. And in containerizations, we are going to use very less resource. That is one of the advantage. When you are going to deploy containerized application in AWS cloud, Azure cloud, Google cloud, or any other location on premises, you are deploying a containerized application that everything is there inside the container. It is portable. These are some of the advantages that you're talking about, right? So that's why you're moving from VM approach to containerization approach. In containerization approach, you are going to use very less number of resource, right? Now see here, let's see, I'm talking about the container only. Container provide the environment to deploy microservice from cloud native application point of view. Now, how to specify how many machines or container to keep running at a particular time? At a particular time, how many containers should run? How we are going to decide? What to do if a container fail? How to connect a container to another container, because one container your user microservice is running, another container your customer microservice is running, another container you have some other microservices running. So how one container is going to communicate with another container? These are the questions. Solution is container orchestration tool, that is Kubernetes. How many containers should run at a particular time? Kubernetes can decide based on autoscaler policy, and based on the autoscaler policy, Kubernetes will decide how many containers should run at a particular time. If a container fail at a particular time, Kubernetes is responsible to recreate that container once again. One container will communicate with another container with the help of Kubernetes. This is the container orchestration tool, and very powerful tool that it will work automatically. We are talking about here. There is right. So here what he talked about is that uh, now the complete things just now we talked about. If you can see here, I want to talk about this. So let me see some scenario here. You see, just right here. I'm just writing here some another scenario is that just see here the scenario here that I'm talking about a cluster. How we define a cluster? Let's see here. This is, or let me just talk about using this payment. See, this is a node. These are the nodes. They're called nodes. When you have deployed your microservice, containerized microservice is running inside the node. So collections of node is called rack. So you can say this is a node and this is a rack. Okay. Similarly, you have this is another one rack. This is another one rack. Collections of node is called a rack. This is also a rack. Right? Collections of rack is called data center. Right? Data center. Right? Similarly, you can see here this one also rack. And collections of rack. Collection node is called rack. Similarly, these are the nodes. We're going to deploy a microservice. Collections of node is called rack, and collections of rack is called data center. This is another one data center. And collections of data center is called a cluster. So this type cluster configurations, this type of configurations is already given to us by GCP. Its name is GKE, Google Kubernetes Engine. This type of cluster is already given to us by GKE. And we don't have to create that. You have to just deploy your microservice inside a particular node inside a rack. I'm just speaking about that for all clouds follow this type of cluster, basic configuration. You don't have to create all those things. It is already given to us. Its name is GKE, Google Kubernetes Engine. What you have to do, you have to just deploy your microservice inside your cluster. That only you're talking about here. Google Kubernetes Engine. GKE or Google Container Engine is a powerful cluster manager, an orchestration system for running your Docker containers. Container Engine schedules your containers into the cluster, keep them healthy, and manage them automatically based on requirements you define. Kubernetes is an open source and based on Google System GKE is a framework for container management and automation. Right, it supports auto scaling. Stack driver is for used for monitoring. So just see here, I'm talking about Kubernetes, Google Kubernetes Engine. So you can see here, this is I've just given one cluster configuration used by GKE. If you go inside GKE, Google Kubernetes Engine, you will find inside you'll find some worker node and some master node. It is very specific to GKE. See, I told you just now, I told you that yes, this type of cluster configuration followed by all the clouds. But this is the idea behind cluster. AWS also have cluster, Azure also have cluster, GCP also have cluster, right? That is the idea behind cluster. Now, how this cluster is actually defined in case of GKE, Google Kubernetes Engine, that we have given it here. We have some worker nodes and one master nodes. These worker nodes contain your containerized applications. It is called pod. Remember, pod is one type of technical name for your uh, deployed application, containerized application. So here inside a worker node, you have an application and the container. So containerized applications together is called pod. Inside one worker node, you can have multiple pods or you can have a single pods inside a one worker node. Standard is one node contain one pod. In each worker node, you have the containerized application should run. This is the master node. As the name is saying, it is going to manage all the worker node. Now here in the master node, we have some four processes, whereas in the worker node, each and every worker node, we have some four processes. Purpose is to manage your containerized application. If it is not running, it is not working, then it can recreate that particular node. Then communication between multiple nodes happened with the help of these processes. Right. So this is the scenario how GKE architecture will work. It has multiple worker node and one master node that have multiple processes. I'm not going into that process for the time being because these are not part of our curriculum. We should know, yes, this is how the GKE look like. Now here, this is the complete architecture of GKE. This is the master node. It has multiple processes, etcd, kubelets, where these are the worker nodes. Each and every worker nodes have a pod. You can have two pods inside one pod in one node, one pod in one node. Pod is containing containerized applications, right? So these are the worker nodes. This is the master nodes. So we are going to deploy the containerized applications inside each node, right? Yes, I'm not going into in depth because these are not part of our curriculum, but we should know, yes, this is how a containerized application should work, right? Now in GKE, Google Kubernetes Engine. So, you'll find, these pods, you can see one master node, multiple worker nodes, right? Right. So if you are going to deploy any applications inside and worker nodes, it will come as a containerized applications. It is defined as a pod. right? So let's see, you can create, there is one master node, there is multiple worker nodes are there. In the worker nodes, you're going to deploy the containerized applications. Now it supports auto scaling, means, you know, that if you have master node and we have the worker nodes contain multiple pods. So based on the current load, Kubernetes can remove some of the instances, or Kubernetes can add some of the instances during runtime, right? So what is this Google Kubernetes engine? Google Kubernetes engine is a powerful cluster manager, an orchestration system for running your Docker containers. Container engine schedule your containers into cluster, keeps them healthy and manages them automatically based on requirements you define. Now let's see the scenario. Just now I told you, yes, this is how a GKE look like. Okay, fine. Now what I want to do is that I want to deploy a containerized application inside a GKE. That is my requirement. If that is the requirement, just see here, I'm just moving inside our Google Cloud and just go to Kubernetes engine, right? Go to Kubernetes engine and just select here cluster. So what we are going to do is that we are going to create a, it's coming, I think. Let me just check. Left side. Go to dashboard first. Okay, now we'll go to Google Kubernetes engine. Kubernetes engine cluster. Now here, what I want to do is that I want to create a cluster, right? So if you want to create a cluster, let's create it. And if you want to create a cluster, you can see here. See, there is, it's as the name is saying here that autopilot cluster 1. You see here, create an autopilot cluster by specifying name and region. See, the thing is that you can see here this how this cluster look like in the image. Right? You can see lots of parameters are there. And if you're starting first time, you're not aware about all those things, right? So autopilot mode will tell you that everything will be taken care of by GCP. Everything from nodes to networking to security, everything will take care of by GCP. That is called autopilot mode, right? So we are going to create a cluster in autopilot mode. And in the region US Central 1, all the regions you cannot create cluster, right? You have to check in which region we can create a cluster in autopilot GKE. Then move next. You may find lots of other parameters. I'm going to use the default parameters for them. And you can just move networking. I'm going to use the default parameters, and using those default parameters, I'm going to create the cluster. It may take some time to create the cluster. I'm going to create a cluster. You can try the same things from your end. As you find, we are talking about task 1, create Kubernetes cluster. That is our first task. So it will take some time, 3 to 4 minutes or 5 minutes. How to check how long time it is going to take? You can just right hit, just click here in this cluster. It is saying see 38%. So configuring, deploying, health check, 41%, right? If you create a cluster, you can see it is taking some time to create a particular cluster, and it is saying that cluster creation can take 5 minutes or more. See, it is saying 56, 59%. So it will take some time to create the complete cluster. And so I'll show you how we're going to move with this, right? And this is the storage, observability. Here are the logs. Can check others. For timing, let's complete it first. One of the cluster will complete. I'll suggest you also do on the other side. Just create the cluster first and create it in autopilot mode so that I don't have to think about other configurations. Let's understand it first, how it work. Then we'll move step by step. Till now it is 67%.
It's taking a while for me too. I'm at 67% as well.
Okay. So we can see here. So it has moved to 83. We're going to do this 3 tasks. One is create Kubernetes cluster. Once it is done, after that we try to deploy and workload. Means we are going to deploy containerized applications inside this cluster. We'll see how a containerized workload can be deployed inside a cluster. Then we are going to access that containerized workload from the cluster. So there are 3 tasks we try to implement. So it is saying done. Let me check if it is done or not. Go in this. It is saying it is completed. It is created. So you can see here the cluster created, and this cluster means type of cluster, right? Now we will say that there should have one master node, multiple worker nodes, right? Let me check. Is there anything? Where is the nodes? Number of nodes. See, nothing is visible. Correct? Nothing is visible. Number of nodes. See here. The cluster is created, but these nodes are not yet visible, not yet available. Cluster is created. Sometimes you may get some errors also when I'm going to create the cluster. It is saying that resources are not available, something like that. You may get some errors, but that is not an error. If you get like that, that is not an error. It is saying that when you are creating the cluster in autopilot mode, it is waiting for resources so that all the nodes will be created, right? Sometimes you may get it. For me, it is not there. So the cluster is created. But if you go inside this cluster, you can see here default zones they have given, but none of the nodes created still now. If you go in the storage side also, you can see that none of the nodes not yet created, right? So I'm just saying that cluster means what? We have nodes, right? Where you're going to deploy containerized application is running. Now, here in case of autopilot mode, when I'm going to create this cluster in autopilot mode, right? These nodes will be visible only when you are going to deploy the workload inside the cluster, right? So now this none of the nodes are visible, right? So what are we going to do next step? I'm moving to the next step. Next step is deploy and workload. Deploy containerized application inside the cluster. So the task 2, what I'm doing, just see here, I'm just moving to cluster Kubernetes engine. So task 2 is done. Check it is done for everyone. Task 1 is done for everyone. This task 1 completed for nodes like this, right? So the next step we are moving, the nodes will be available when you deploy the workloads. In case of autopilot mode cluster, when you deploy the workloads, then only the nodes will be available. Let's see the next step or task 2, right? So let's go to Kubernetes engine workloads. Let's go to workloads. Now see here, when I'm going for workloads, it is saying that you can create an workloads containerized application for a particular job or task, or to deploy a application inside the workloads. You want to deploy containerized application, right? So what I want to do is that I want to select create deployment. So select create deployment. Now, when you see create deployment means I want to do the deployment here. You can get the code from GitHub. So if you want to get the code from the GitHub, you can use new container image. In that case, you can connect with your GitHub account or Bitbucket account. You can connect with your GitHub account. You have to define the GitHub repository, Docker file path, all those things. If you want to get your code from the GitHub. For the time being, in case of in this current examples, we are going with an existing container image. GCP has already given one existing container image, that is an nginx. So since we are learning first time, right? So better to go with existing container image, nginx application. Right? Okay, and then move add a container. I'm not going for this for the time being. Click continue. It is going to do this deployment. Here, key and level is mainly used to uniquely identify that particular containerized that container deployment. Then configuration YAML. So when I'm going to deploy this containerized image, we are going to use this YAML file. This YAML file is automatically created by GKE. And if you're familiar with Kubernetes, already you know that it is going to create 3 replicas for this deployed applications. These are the if you know Kubernetes architecture, you're very much familiar with this YAML file. If you're not familiar with, leave it for the time being, because this file is automatically created by Google itself, GKE. Now this cluster that I'm going to create, right? Let's continue and then create deploy. So what we are going to do is that we are going to deploy a application that is given by GCP only. inside our GKE, Google Kubernetes Engine. Let's see how it look like. Next, application getting deployed inside the Kubernetes cluster. See here, creating workload, waiting for pods. Now this time the pods gets created inside your worker node. Pods gets created in the worker node. Now you may get some error, something like that. Don't think it is an error. You may find red symbol like that. Its meaning is not error. Its meaning is does not have minimum availability. It is searching for the minimum availability. So if you go here, you may find this type of things does not have minimum availability and 5 more issues. See here, out of these 3 pods, none of the pods gets created. So you have to wait. You have to just refresh this. Just you have to wait 2 minutes, and you can see this error will go automatically. Whatever you find here, this error will go automatically. Just you have to refresh it. It is searching for, see here, 1 pod gets created out of 3 pods. Out of 3 pods, 1 pod gets created in 3 worker node. Let's refresh. You can see all the 3 pods gets created in 3 worker nodes. It is okay, right? So your Nginx application gets deployed in 3 different pod in 3 different work node. Let me check. If you go inside, just see here. Just see here. This Nginx. This is the master. This is the 3 different nodes. So just I told you, right? This architecture. The same application gets deployed in 3 different nodes as a pod by default. 1 node, 2 node, 3 node. So 1 node is saying 1 pod here in this example. This is the first node, second node, third node. First pod, second pod, third pod. Right? 1 node and pod, it is saying in case of autopilot mode, it is same. Right? So it's deployed in 3 different pods in 3 different nodes. If you want to see each node, just open that. You can see this is running, and this is one containerized application that gets deployed inside 1 pod. Right? Okay, fine. So let's move left side. Still now it is saying does not have availability. Just refresh. Yes, it is there, right? So what we have done the third task. The second task, deploy workloads. So workloads gets deployed inside our pods, and this is the default one, right? So we can see our cluster is ready. Now you can see a number of nodes. It should show one. So next, I'm doing the last step. Last step is saying that the application that is deployed in 3 different pods, the workload that is deployed, you can see the workload that gets deployed in 3 different pods. I want to consume that workload. See, it is changing. In case of autopilot mode, it is changing. Sometimes 1 by 1, sometimes 3 by 3. Now the point is that now how I can consume the resource that is deployed, right? How I can consume. So just go inside Nginx 1. And if you go down, you'll find an option called expose. Again, I'm saying go to Kubernetes engine, workloads, select your workload, and go down. If you go down, you'll find one button that is called expose. That means I want to expose this workload using an URI. I want to access the workload using an URI. So click expose. When you click expose, that's just see here, some questions came for load balancer setup, right? See here, the service type. So this will be exported in the by default port number is 80, TCP protocol. If you want to add a load balancer, it is going to take a default load balancer. Or if you want to configure a load balancer, that also you can do it. For the time being, I'm going with the default load balancer setup that is given. Now just click expose.
Expose for external IP, right?
Okay. You can see here, it's exposed now here. Once it is done, you'll find. Once it is done, we'll find here one link called external endpoints. See here, this external endpoints with the port 80. Just click here and you can access the applications that is running inside the pod, inside your node, inside your cluster. And it's working fine.